universe's first stars flooded the cosmos with water, study says. Water is the essential of life. Every living thing on Earth contains water within it, and Earth is rich with life because it is rich with water. This is a very amazing discovery, isn't it? Who knows how much water we have in our universe? Now, this fundamental connection between water and life is partly due to water's extraordinary properties, but part of it is due to the fact that water is one of the most abundant molecules in the universe. Made from 1 part oxygen, 2 parts hydrogen, its structure is simple and strong. The hydrogen comes from primordial fire of the Big Bang and is by far the most common element. Oxygen is created in the cores of large stars, along with carbon and nitrogen as part of the CNO fusion cycle. And because of its origin, we're generally thought that oxygen, the correspondingly water, grew in abundance over time. From the first stars to the present day, each generation casts oxygen into space in its dying moments. So while water was rare in the early universe, it's relatively common now, but a new study suggests that that is not the case. Astronomers categorize stars into populations depending on their age and metallicity, where metals are any elements other than hydrogen and helium. The youngest and most metal-rich stars, such as the Sun, are called population 1. Older stars with fewer metals are population 2. The oldest stars, the very first stars to appear in the universe, are known as population 3. And though we have observed population 3 stars directly, they would have been enormous stars made entirely of hydrogen and helium. The first seeds of everything we see around us, from oceans to trees to beloved friends, from within these first stars. They formed in these first stars. And the new study of the ARXIV suggests that population 3 stars also flooded the cosmos with water. In their study, the team modeled the explosions of small 13 solar mass and large 200 solar mass early stars. The large stars would have been the very first stars formed from the primordial clouds, while the smaller stars would have been the first stars to form in early stellar nurseries. Not quite population 3 stars, but with very low metallicity. And when the smaller stars died, they exploded as typical supernova, but when the large stars died, they exploded as brilliant pair instability supernova. Based on simulations, these stars would have greatly enriched the environment with water. The molecular clouds formed from the remnants of these stars had 10 to 30 times the water fraction of diffuse molecule clouds seen in the Milky Way today. And based on this, the team argues that by 100 to 200 million years after the Big Bang, there was enough water and other elements in molecular clouds to form clouds for life to form. And whether life actually did appear in the universe so early is an unanswered question. There's also the fact that while water formed early, ionization and other astrophysical processes may have broken up many of these molecules. Water might have been plentiful early on, but the universe entered a dry period before population 2 and population 1 stars generated the water levels we see today. But it's possible that much of the water around us came from the very first stars, the scientists find. This is from Universe Today on Science Alert by Brian Koberlin. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.